Okay, welcome to today's session. This is Jyoti Dodia, and I'm very pleased to have Chris Parsons join us today to cover PowerAI Vision and iOS. We advertised it as machine learning from concept to reality, and that is what he will be covering. So you may have come across to this session in two different means. One is via the Power Virtual User Group webinar series that have been running for a while, or the other method may have been via the IBM PowerAI London Meetup group. Either way, we're covering the same session, and the material will be recorded and shared with you afterwards. So without further ado, let me hand over to Chris. Over to you.
Great. Thanks, Jyoti. So nice to kind of virtually meet everybody. As I said, we're talking here today about taking machine learning from a concept, an idea, and making it a reality, integrating it into a user-facing application. So I'm Chris Parsons. I work for IBM in the UK as a machine learning engineer. So my kind of primary role is to go out and work with IBM's customers that are looking to build their own machine learning systems using frameworks like TensorFlow and Caffe, and to really help them get the most out of our portfolio. So as you can see on this slide, my Twitter handle is @ChrisParsonsDev. Do feel free to give me a follow and reach out with any questions you've got. Happy to sort of carry on the conversation offline. Be good to hear from all of you. And of course, if you've got any questions that you think actually you don't necessarily want to tweet me, let me know, and I can provide my email address as well. So what is this talk then? So there will absolutely be a live demo. We're going to show some live code. So if that's why you joined, fear not, we'll get to that. But I just want to spend a few minutes at the beginning of this going through some context, talking about why we're doing this, what the motivation is for IBM, but also for us as developers, as consumers of this service. I'm going to talk about AI Vision, which is one of IBM's software products, and that's designed to kind of accelerate building image recognition, video classification models. So I'll go through what that tool is, the API that it provides, and how you can build things there. Also going to do a really quick crash course into iOS development. So I know that for many people on the call, iOS development will be a new thing, maybe not 100% familiar with it. So I'm going to go through sort of some fundamental concepts. I'm not going to go into loads of detail at all. That's not really the purpose of this talk, but I just want to touch on it a bit to kind of give some familiarity. Then I'm going to talk about some of the design choices that I made, some of the things that you might want to consider if you're thinking about building a system like this for yourself, if you're thinking about integrating AI into your applications, the kind of design choices you might want to make. And by design, and you'll see this in a minute, I don't mean user interface design, I mean kind of architecture choices. You'll see when you see the app that I am absolutely not a user experience designer by any stretch of the imagination. And I'm going to finish up with, as I said, with that demo and run through that live example. My plan is to leave time for questions at the end, but if you do have questions, as Jyoti just said, feel free to drop them in the chat, and then we can go through them as we go through this session as well. Okay, so why are we doing this then? What is the kind of the strategy here, and how does it fit in? I think we're starting to see a couple of different branches within artificial intelligence or within machine learning. In fact, I think we're seeing 3 or 4. The first, and I think this is the one that we're most familiar with, this is around the API. This is around consuming a service. Maybe it's cloud-based, but this is about consuming a service that already does something out of the box. And if that fits your particular use case, then that's fantastic. You're good to go. You've got everything you need, and you can easily integrate that into your applications. The second is for your kind of hardcore data scientists and machine learning engineers that want to get into the weeds, really want to get into the nuts and bolts and want to build things from the ground up. They want to be using TensorFlow, controlling where the model is, getting involved with CUDA and some of those other GPU frameworks at a really low level. And the third, and this is kind of why I put this talk together, the third, I think, is where the majority of users will sit. That is the group of people that want to add machine learning, AI capabilities into their application, but don't necessarily want to go and have to teach themselves TensorFlow or teach themselves how to do data science. And also, those kind of... Yeah, sorry, go ahead.
The screen is still showing agenda slide.
Yes, that's right.
Okay, that's fine. We're just checking.
Yeah, thanks, Katie. Yeah, so, and also, I think this is the other user group that wants to integrate it into their application, but doesn't necessarily want to use those consumable APIs, because maybe they don't fit their use case. Maybe it's not exactly what they were looking for. They want to go into slightly more detail than those APIs will afford them. How do they do that? How do they build custom specific AI applications without going into loads of detail? So that really is the fundamental motivation for this talk. Okay, let's move on. So PowerAI Vision. This is an IBM software product. It runs on top of PowerAI, on top of IBM Power as a hardware platform, and I've gone into loads of detail about that previously, and in fact I did a deep dive into AI Vision in a previous talk as well, so if you're interested in more information, do check that out. But fundamentally, it is a software product that is designed to do the end-to-end process of building a custom AI for image classification without needing to write a single line of code. So you go through creating your data set, to training your model, so training the AI, to deploying it, so deploying that API as a web API so you can interact with it and integrate it into your applications. And you can go through this entire process from one browser-based GUI. So there's no need to kind of get into the weeds and start writing hundreds of lines of Python. You can get going really quickly and without necessarily having a wealth of prior experience. So it's about making the data science easy, as it says here. This is about putting the hands of doing data science in the hands of the subject matter expert, right? The person who understands the domain. So if we take the example of detecting different types of cancer, the subject matter expert there is your doctor, right? It's the doctor that understands whether or not it's one type of cancer or another. But that doctor shouldn't have to go and teach themselves everything about Python and everything about TensorFlow to build that model. And this is what AI Vision lets you do. AI Vision lets you build this model with domain expertise. So understanding your problem, understanding your customers, and knowing what you want to achieve, but not necessarily having all those data science skills. So it puts the data science back in the hands of the subject matter expert. Now, if you are a data scientist, and I'm sure many of you on this call are, you can still do a lot of customization. So it's about making it easier for you to do the stuff that you need to do. So to add custom models, to change the way your network is defined, all of that kind of thing, but from an easy to manage interface. So it's about accelerating that life cycle. It's about collaboration as well. It's about working with teams on data science. I think data science is very much a team sport. So it's about working with other people in the organization, other domain experts, and building up a better picture of what's going on. And as it says there, it's about doing that end-to-end process in one place. The other really cool thing it can do, although I'm not going to show you that today, but the other really cool thing it can do is handle video workloads as well. So we're not just talking about working with images here, we can also handle image and video workloads in one place. And the process is very much the same. So it's got an API, as I mentioned. So AI Vision does the whole data set curation, model training process, and it also lets you deploy it as an API. Don't know if anybody on this webinar has tried to deploy a machine learning model that they've built, but it can be difficult. It's not necessarily trivial to do. In fact, I've done it a number of times, and I still don't know that I've massively got my head around it. It's a tricky thing to do. So AI Vision aims to make that easy by providing an interface that will automatically deploy your API. So it'll automatically take your model and deploy it so you can integrate it into your application, which is awesome, frankly, because it takes a massive headache away. That API works like this. So for those of you that are web developers or have got experience developing on the web, you'll be familiar with this. This is a technology called XHR. Now, XHR stands for, as it says on this slide, XML HTTP request. It's basically a standard procedure for packaging web requests. So it basically boxes them up and means that they're a standard format. Now, AI Vision is XHR compliant, which means that the API talks in this way, in this standard way. And that's great, because that means that we're using these open standards. So anywhere where you can perform standard web requests, through Node.js, through a web browser, or even in a mobile app, like I'm going to show you later on, you can use this API, which is really great because it means it can be integrated into applications really quickly. And I just wanted to spend 2 minutes talking about how XHR works, just as a bit of context. So here we see on the left-hand side of this chart, we've got our standard web browser, our standard application that is searching for flights. So in this example, we've seen this hundreds of times. We've got a web form where we've got a from and a to field. So we say, hey, you know what, we're flying from London to Tokyo, and then we hit search. When we press that search button, what happens is the application packages up that request into a box, into an XHR request that basically has a standard set of fields that says, hey, this is where we're going from, this is where we're going to, and sends it off to the server. Then we send that request over to the server over here on the right-hand side of this chart, and the server knows how to unpackage it because we're dealing with standard protocols. We're dealing with a standard structure. So the server looks inside that box and says, okay, I know where you're going from and where you're going to. I can use that to search against my database of flight information, and I can send you a response back. So then the web service, our web server, packages up that request or the response to that request and sends it back to the browser. Again, in that standard format, in that standard box. And our browser can unpackage that box and render a new screen for us. So that's an XHR request. And as I said, AI Vision, PowerAI Vision, is XHR compliant. So in our example that I'm going to show you later on today, what we're going to do is basically have a simple app that is going to package up a photo of a bird into an XHR request, into a box, send it to a web service, which we're going to automatically deploy on PowerAI Vision. The web service is going to unpackage it, look inside the box, see a photo of a bird. It's then going to classify that against the model that it's built automatically for us, and then it's going to put the response back in a different box and send that box back to our mobile app. That's the fundamental workflow that we're using. And I cross my fingers a bit there because we're going to do a live demo. So, in theory, that's exactly what will happen. But it's a standard way of communicating, and it's absolutely awesome that AI Vision follows this protocol because it makes it really easy to integrate into your existing apps or to use standard web communication technologies. So the second thing is JSON. Again, web developers in the room, you're in for a smooth ride here. JSON, not JSON. JSON is JavaScript object notation. It's a standard way of declaring objects for web traffic because they're easy to read, as you can see here on this slide. They're also easy to manipulate, so developers can easily get to the bit of the data they want, and they're very extensible, so you can customize them to do what you want. Again, these are a standard way of web traffic or web communication. So AI Vision is also JSON. So the response you get back from the server, the XHR response we get back from the server is JSON. So this is an example of a response we get back. So we've sent it a photo of a bird. In this case, it's a loris, which happens to be a gull. So we sent it a photo of a gull, and we've got this response back. So in here, we can see we've got a classification. So here, under the classified parameter, we've got the classification. So here it says, you know what, I think this is a loris, I think this is a gull, and it also tells us its confidence. So in this example, it's 100% confidence that it's 100% confident that the photo I've sent is of a gull. We've also got a couple of other bits of detail there. One is the image URL. So once we've sent that request, it stores that image on the server in a temporary directory, which is automatically cleaned up. But if we want to leave it there and maybe add it back to our dataset, we can absolutely do that. So it gives us a URL where that endpoint is, and it also tells us the result, so whether or not the classification was a success or whether or not the model failed to classify it. So this is an example of the response we're going to get back. But as you can see, it's all fairly easy so far. It's fairly easy to understand how we're going to manipulate this, how we're going to integrate it into our app, and how we're going to get sensible responses from this API that's deployed automatically. So that's AI Vision in a nutshell. What about iOS application development? So there's a few things that we need to know about iOS application development before we get started into this demo. The first is iOS apps, or one of the primary languages for writing iOS apps, is Swift. Swift is an open source programming language. It was originally written by Apple, and now it's completely open source, so it's community driven, community contributions are accepted, and it's fantastic. It lets you do some really cool things, and we'll go into the code in a couple of slides time, but we can get into, it does some really powerful things which make it useful for application development. The second thing is, when you're building an iOS app, there's this concept of storyboards. Now, storyboards are basically an application flow. So they describe your user journey through an app. If we consider the apps we use every day, there will be storyboards that describe how they work. So if you look at the Messages app, the first thing you look at is a list of all of your messages. And if you tap on any of those, you sort of segue to the next screen that shows you more detail, your message history, and it lets you reply and stuff like that. So the storyboard is that user journey. Now for this app, I'm going to show you the storyboard, but it's really, really simple because we've got a basic app. The next thing is we also get, when we're doing iOS development, we get this toolbox called UI Kit. UI Kit does exactly what it says on the tin. It provides us all of the tools we need to provide a user interface. So it gives us all of the buttons and labels and image views and switches that we might want to build an app. Now, you don't have to use UI Kit, you can do things yourself, but it gives us a really good skeleton to start building things really quickly, which is why I've chosen to use it. The final piece of the puzzle is the iOS network stack, which again, kind of obviously does exactly what it says on the tin. So this is about providing a series of tools for doing network communication in iOS. So all of these are available in Swift, in Xcode for iOS application development. So that's pretty much all you need to know. You're now all qualified iOS app developers, or you certainly know enough to understand what's going to go on in the demo. So this is a storyboard. As I said, it defines user navigation. So it defines your user journey through an app. It makes it really easy to add and manipulate UI elements. So it makes it easy to customize your UI, add those buttons, add those switches, and it also makes it really visual. So you can easily imagine or easily visualize the workflow. So how your user is going to go through your app. So in this example, this just shows a slightly more complicated storyboard. So there's multiple different screens here. We've got our table view, and then we've got other pages and stuff in here. But you can go into as many different views as you want. So this scales to as many different views as you need. But again, for this simple app, we've only got one view. But I just wanted to show you what the storyboard could do, just to give you guys a flavor of the kind of customization you can do, the kind of depth you can go into with this stuff. So the next thing we need to do, or the first bit of code that I'm going to show you, is getting images. This is our first kind of challenge. Now, I've got two functions for getting images. The first lets users choose an image from the album. So maybe they've taken a photo of a bird previously, and they want to classify it at a later date when they've got network access or something like that. So we've got choose image from album, which lets us obviously pick an image from the device album. And we've also got choose image from camera. So should our users want to upload an image from their device camera in real time, they can do that. So these are the two functions we've got. The first one, you'll notice there's one difference between the two. If you look at the source type, that's what changes. So the first function, our source type, is the photo library, the device camera roll. The second one, the source type, is the camera, so it's going to get it live from the camera. I was actually doing a similar talk, a talk on the same subject a few weeks ago, and I sort of said, I've put the camera in there, but I don't imagine anyone will have a photo of or have an actual bird in the room for us to take a picture of, and some smart guy in the room got a picture of a bird on his iPad and told me to take a photo of that. So I've disabled it for this demo, although it's a webinar, so I'm slightly safer. But yes, so the app lets you pick images from the device album or from the camera roll. So that's how we do that. Then we've got our network request. So I'm going to go into this in a bit more detail when I show you the code, but fundamentally we're creating a network request that lets us send that data. So we've got if we go into this in a bit more detail, which I will do later, as I said, we've got our URL right at the top, so that's our API, that's where our server sits, that's where our AI Vision instance sits, and then we've got some code that creates our request and uploads an image. So it adds that photo, as you can see there, the file name, the upload PNG. So it uploads that photo to our server and sends that in the body of the request. I'll go into much more detail in that later, including what bits of this code you'd need to change to make it suit your model. Should also add at this point, I've open sourced all of this code. It's all available on GitHub, so you can go and get access to all of this and integrate it into your applications, start to build things with it and manipulate it today. So we've got our ability to get images from the device, and we've also got our network request. So all that we're left to do once we've done this is build our AI, to build our AI in AI Vision. Once we've done that, we get the response back. So this is the process of dealing with the response. Now remember I said it was JSON, so it's fairly easy to manipulate, as you can see here. And all we're going to do is get the classification. So we're going to dig into the response we get and get that classification back. And then we're going to update the text labels on the screen so that the user can see what the classification was and how confident we are in that classification. So we're not doing anything hugely complicated here. We're not this app's not going to take over the world, but it's just about building something simple to show how quickly you can get started with it and how easy it is to manipulate the responses from this stuff. So, design choices. What design choices did I have to make when I built this app? There's lots of things to think about when you're going about building an application or integrating machine learning into your existing apps. And I just wanted to put a slide together or touch on them briefly, some of the considerations you might want to make. So the first thing is inference. We've got two notions when we talk about machine learning or when we talk about deep learning. The first is training. Now, I think that's the bit we're all most familiar with. So that's the training of the model where we teach it to understand about our data set. In this case, hundreds of photos of birds. That's our training. The second phase is inference, which is once we've done that training and our user has a new photo of a different bird and we send that up to the server, what classification do we get back? So that's inference. So the first phase is training that we're all familiar with. The second is inference. Now, training, fairly obviously in this example, we're going to do remotely on the server because that's your heavy lifting job, right? That's the bit that requires computational power. That's the really complicated challenge that we need our GPUs for, that we need our heavy lifting compute for. But inference, that's only one image, right? So I don't necessarily need hundreds of computers to do that, unless of course I'm expecting to have thousands of concurrent users. I don't necessarily need a big server farm to do that. So where do I do my inference? Do I do it natively on the device, or do I do it over the network? So do I do it over the device network, be it 3G, 4G, or Wi-Fi? How do I do that? And I think there's a few things to think about. The first thing is, where will your users be? And I don't mean what device will they be on. I don't mean web or Android or iOS. I mean physically, where will they be, right? Are they going to be out in the woods where they might not have a data connection? Are they going to be at a football stadium where the network might be seriously overloaded, right? If there's lots of people trying to use the network, we all know it slows right down. So where are your users going to be? Are they going to be somewhere where there's going to be good network access, in the home, over Wi-Fi, in a built-up area, or are they going to be somewhere more remote than that? In this example, even though we're pulling together an app that recognizes different types of birds, so you could fairly safely assume that our users are going to be remote, I've chosen to do things over the network. The reason for that is that doing things over the network in this example means that we can update the AI, we can add new birds, we can teach it about new things without having to update our app. So if we're doing it natively on the device, so we're not doing a network call, every time I change my AI, I'll need to submit an app update. And that's going to annoy our users, right? Constantly updating the app is going to frustrate our users. So in this example, we're doing it remotely. We're doing it over the network. The other things to consider are, how quickly do they need a response? Is it urgent that we get the result back to them? Because if it's really time sensitive, then we probably want the inference to be done in the device, which would be much faster. We don't want to be making network calls if we're trying to do stuff in a time sensitive environment. Now, again, for this app, we're classifying different birds. I think we can be fairly safe that this is never going to be done in an emergency situation, so we can slow things right down and we can make network requests. And of course, when I say slow things right down, it's all relative. It still happens really, really quickly, but we are still, it's not quite as quick as it would be if it had been on the device. The third point is, how much do I care about my user's battery, right? And as users of these devices, I mean, one of our primary concerns is battery life, right? We've all been there where it starts to tell us that there's 20, 10, 5, no % battery life left. And that's because we're asking our device to do lots of work. If we move the inference to the device, that means we're moving a lot of the compute work, a lot of the processing to our phone, right? So how much do we care about our user's battery? Are we bothered? Do we mind if we consume all of their battery? Or do we want to save their battery life so they can keep using the app for longer? And we have to think about the user experience here, right? As users of these apps, if the app consumes all of our battery life, we're just going to uninstall it. So that's another advantage of doing things over the network, is you can reduce the power consumption of the device. You can reduce the load of the app. The final consideration about inference is, how much space do you want to use on the user's device, right? The second thing to battery life that I think is constrained on phones is the space on the device. If you're going to have lots of, if you have lots of inference in the app, that's going to make your app bigger. If you deploy your model to the app, if the model is physically in the app, you're going to consume more of the physical storage on the device. If you consume lots of the physical storage, then of course users aren't likely to keep the app on the device. They're going to think, well, this app's pretty big, I'd rather have more music on the device, that kind of thing. So that's another consideration. Just some of the things you might want to think about when you're looking at how to deploy the app. The final choice I had to make was about XHR, so my XML HTTP request. So once I'd decided to do things on the web, once I'd decided to do inference over the network, how was I going to do that? Now, there are a few choices when you're doing networking on an iPhone or even Android about how you do that. There's hundreds of libraries out there that can make it really easy for you. Now, do you want to do things natively on the device, or do you want to kind of speed things up and use one of these libraries? In this example, I've done things natively because it's lighter weight, so the iOS networking stack is lighter weight. Yes, you have to write slightly more code, but it also demonstrates how you would do it if you didn't have access to any of those libraries. So I've gone for inference over the network, and I've gone for a native network request. So those are a couple of the design choices that I've made. And just some of the things you might want to think about when you're looking at how to integrate this into your applications. So That's it. On to the live demo. Let's actually show this working then. So in the next 20 minutes or so, because I'm conscious that I want to leave time for questions, we're going to build a data set in AI Vision. We're going to train that model, so we're going to build our own custom AI using this toolchain. We're then going to deploy that model as a web API. So we're going to take our model, take our trained model, and deploy it as a web API. Then we're going to build our iOS app. We're going to connect the API to the iOS app, and we're going to test it. So we're going to see if it works. And of course, this being a live demo, it is absolutely guaranteed to work, I promise. So, right, here we go. Let's get started. So this is, go ahead. Sorry, Jyoti, was that?
I was just going to say, while Chris is changing screens, which you did quite quickly, if anyone does have any questions, please post them into the chat window, just a reminder.
Yeah, absolutely, do fire away. So this is AI Vision. This is our AI Vision instance. We're running in our data center in London. We've got a power server running the AI Vision software stack. And as you can see, it's a simple GUI. It's a browser-based interface that makes it easy to get started with these things, just as I promised. So what can we do? Well, the first step is to build our AI, to build our data set. So the first thing we're going to do is go over here to add data set. Now, here we've got a bunch of choices. We can pick for we can import from a zip file, or as I said, we can work with video data. So image classification is what category does this image fit into? What type of bird is this a photo of? Object detection is where in the image is a bird. The third one is the third one, import from a zip file, is I've got a bunch of photos on my laptop and I've converted them into a zip file. Can I upload them into one go? And the third one is video data. I don't want to work with images. I've got a bunch of videos. Can I still do that? Right, so you've got a bunch of different choices right out of the gate. So the first thing is for this simple app, we're just going to classify the birds. So we're not going to look for where they are in the image. We're just going to classify them. So I want a data set for image classification. Now I give my data set a name. So let's call this one test birds, because we're just doing this demo here. So the name could be absolutely anything as long as you and your team know what it is. So we've got a bunch of different scenarios now. So we've got flowers, we've got landscapes, you can see Chinese food on there as well, or if none of those fit, you can select others. For this example, I'm going to pick others because none of those particularly fit. And what this does is, behind the scenes, is it gives AI Vision a bit of a clue about how to integrate it into your, or how to start defining the AI, how to start training the model. So if you pick flower, it makes some assumptions about your data set that help to speed up that training process. If you pick others, it starts from square one. So it does a more primitive search, which might take a bit longer and be a bit less accurate. So it's just one of the ways you can tune your algorithm without going into tons of detail. So I'm going to pick others here because, again, as I said, none of those scenarios particularly fit this use case. So add data set. Okay, here we are. That's it. That's all you need to do to create your data set. We now need to give it some photos of birds. So to do that, we click Add Category, and we give our category a name. So you saw in that demo example, in the JSON, we had the category Laris. So that would be our category name here. So this is the type of classification you've got. So how many categories do you want? Do you want to recognize BMW and Mercedes? Do you want to recognize different types of birds? Whatever it might be. Each of your categories gets a different name. So here we can have big bird, for instance, and we can add that category, and that's it. That's all you need to do. And we repeat that process for however many categories we want. So we can rename them as well, we can delete them, or we can add more categories. So if later on we come along and we think, actually, do you know what? I want to have more birds in my data set. I want to recognize more types of car. You can come along and do that here. Now, all I have to do at this point is add photos of Big Bird. Now, to do that, it's really simple. All I do is drag and drop the photos of my bird into this box here where it says upload pictures. Now, if history teaches us anything, it's that as a human race, we're pretty good at uploading photos of birds or anything to the internet. We're pretty good at that. rightly or wrongly. I'm not here to discuss that, but we're pretty good at uploading images to the internet, so it's really easy to do this. Anybody can get images from their computer and upload them into this service. Or if you want to upload loads at once, you can select some, and you can find that directory on your Mac or on your PC and upload them from there. So that's it. That's how you create your data set. I'm not going to make you all sit here and wait now and watch me upload all of those different photos of birds, but what I'm going to do is skip to one that I did earlier. Here we go. This is our data set of birds, and this is what the finished article looks like. So here we've got lots of different categories, and we can see the images that have been uploaded. So from here you can delete the image, say if it's the wrong bird, somebody's uploaded it by mistake, or it's not a very good photo, or you can view the original so you can see it in some more detail. There he is looking at us. And just, for proof that there's different types of birds in here. Here we go, we've got another type here. A disclaimer, they're all known by their Latin names. I am not an ornithologist, so I don't know if the Latin name is 100% correct, but that's not really the point of this demo. The point of this demo is that we've got a system that will recognize these different categories. So we've built our data set, right? We've got our data set. We know we're going to build an AI that recognizes birds. That's all built. The next step is to build our AI. So logically, you head down these tabs over here on the left-hand side. So we've gone to My Deep Learning Tasks. So here, I'm going to select Create a New Task, and I'm going to choose whether or not I'm doing classification or detection. So classification, again, is what type of bird is this? Object detection is where in the image is there a bird, and what type of bird is it? So for this primitive example, we're doing classification, so I select that. We give it a name. Let's say, let's call this Birds Webinar. Okay, and then we've got some choices. So we select our data set, so we can go with test birds. There's loads of other ones in here. There's dogs with fried chicken. Not really sure what that's about, but I'm going to pick birds. So this is the full data set from earlier on. And then I choose my training strategy. So this is the really interesting thing here, is I can choose precise first, which will go through more iterations, it'll spend longer training, and it'll make a more accurate model, so it focuses on accuracy. I've got speed first, which, as it says on the tin, does the opposite. It focuses on speed and doing things quickly and doing fewer iterations through the training data. Or, if I'm a data scientist, I can click Customized. If I pick Customized, it'll give me some of the hyperparameters, so I can modify those here. So the number of iterations I go through, my learning rate, the decay, that kind of thing, and I can upload custom models, custom networks here. However, in the interest of time, I'm going to go for speed first and just have things done quickly. So we've got our data set. We now need to train our AI. To train our AI, we just click this button. And it then tells us, that it may take 1 whole minute to complete. Are we happy with that? So I'm going to say, yep, I sure am. And it's going to go off and train. So what's happening now, as you can see, it's pre-processing. So it's going through all of those photos of birds, and it's making sure that they're the same size and they're a similar resolution. And now it's moved on to training. So it's starting to train our model. And here you can see it running through those iterations. So it's happening really quickly. It's starting to train our model to go through that data. Now, this isn't particularly accurate, right? This is 34% accurate because it only went through the training data 100 times, and we've got lots of photos of birds there. But if you go through more iterations, if you go for precise first, you can be much more accurate. So that's it. That's all you need to do to train your AI, right? And so far, I've not written a single line of code. Right? I've not done any data science other than curating my data set. It's all been really accessible, it's all been really visual, and it's made it super easy to get started. So we've got our AI now, we've got it trained. What do we do next? Well, we need to deploy it, right? We need to integrate it into our application. So let's go to My Trained Models. These are the models we've got here, and you can see really quickly at a glance, based on their categories, what they represent. We can see the accuracy of the model and when they were created. So we know when the models were created, which ones were our latest, and how accurate they were from this one view. So if we look all the way down here, we've got different ones. We've got a more accurate birds demo down here. Look, this one was 90% accurate or 95% accurate, different things like that, right? But we want to deploy it. We want to make it so our app developers can integrate this into their app, okay? So the first step we've got is over here, we've got a couple of options, right? The first is actions, right? So I can delete it if I think, actually, that was a really rubbish run. I want to delete that. I want to clear it up. I can export it as a zip file. So if I want to integrate it natively into the app, I can export the weights file I need. I can export the cafe model as a zip file and put it wherever I want. I can stop using the tool at this point if I want. But if I want to do things quickly and easily and get up and running and integrate it into my app, I can deploy it as a web API as well. So to do that, all I do is hit this deploy button. Okay, and then it says...
Full of questions.
Yeah, sure.
Might be a good time to take those.
Please.
So one of the questions is, can this be used for unsupervised learning? Like, can I upload my data set and then have a system do clustering and then have me add the labels afterwards?
Yeah, great question. So unsupervised learning. So from an image classification point of view, no, what we're doing is supervised learning. In fact, we're doing a transfer learning on a supervised data set. From a video perspective, we can get slightly closer to that, yeah. So from a video data platform perspective, we've got this process. There's a feature called auto labeling, and what that will do is you upload your video footage and you pick, say, 10 frames from it, and you perform classification on those 10 frames. Maybe you do the object detection and classification on those 10 frames. Then you could hit the auto label button, and the system will automatically label the rest of the frames in the video based on the 10 or so you did. So we're kind of doing a hybrid of them both. So it's not quite true unsupervised learning. We're not quite doing the clustering, but we will automatically extrapolate the labels that you've written to unlabeled data. And that's really powerful because, of course, that makes your training ultimately more accurate. It gives you a larger data set, potentially. And the system will notify you if it's not sure of a classification. So if it's not 100% sure of what's going on, then it will say, I think this is, say, a pedestrian, or I think this is a car, but I'm not 100% sure. And it'll let you go in and either delete it or change the classification or confirm that it was right. So we can kind of get somewhere close with video. I hope that answers your question.
Thank you. And there's a couple more that's come to me privately.
Sure.
Just carry on. So is there a limit in training GPU capacity using this tool? For example, what if I want to train a model with 1 million images?
Right, okay, yeah. So where are your thresholds? Ultimately, that depends on your system environment. So this system here has, it's got 4 GPUs in it. So, I mean, the more GPUs your environment has, the more it's set to consume. That's part of the install configuration process. But you do raise a good point there, which is the more images I have, the longer training takes. So the ability to be flexible with the scale of my environment is important. So yeah, you can completely customize that during the setup phase. You can also customize how many GPUs your model deploys to. So when you deploy your model for inference, you can choose whether or not to deploy it to one or many GPUs, and that'll let your application scale.
And then another question from the same person. How can you combine several models to do, for example, 1, detect the item, 2, extract details such as color, texture, and 3, subcategorize the item, for example, a black leather jacket?
Sure, yeah. So you're really, I guess, limited there by your imagination and the depth you want your API to go to. So the first thing you can do is add more categories to your data set. So you can be specific and say that this is these are all things that are red or blue, and these are all things that are cars or boats, and that kind of thing. So you can add the granularity that way. Or you can create multiple data sets, run multiple APIs, and then when you integrate them into your service, make several calls. So if I were to do that, what I would do is I would wrap the AI Vision endpoint. So on AI Vision, I've got my API that I'm just about to deploy. Here, I'd have maybe 5 or 6 APIs that do the 5 or 6 things I want to look for, like the color, what the object is, the object detection piece. So I'd wrap all the APIs in a simple web app, maybe in something like Node.js or something, that I could even deploy on the same server. So I've got the same server making the API call, so it really lowers my latency, and then I have my end app, so my iPhone app or whatever it is, calling my wrapper, if you like. So it calls my Node.js app, not AI Vision, and then my Node.js app will return exactly as you said, so a black leather jacket or whatever that might be. So I'm making multiple API calls to the same server, so it'll be really quick, and I'm moving that data around as required, but my user experience, so my iPhone app is only making one API call, which will improve things. The other advantage to doing things that way, so giving yourself a little wrapper API, so writing your own custom API, is that you will be able to exit and terminate if you're not doing, or if you start to head down a certain route. For instance, if the image that gets uploaded is a leather jacket, you might then know that you don't need to do object detection, for instance. So where in the image is the black leather jacket? Because you've already found one, so you don't care. So if you wrap it up in your own app, you can control the application flow. You can control how the API works in much more granular detail, and that'll help you define performance.
Thank you. I think that's it for the moment.
Okay, no, they're awesome questions though. Please do keep them coming through. They're fantastic questions. And if I didn't go into enough detail in those explanations, please do, holler at me afterwards, and I'll happily kind of go into more detail or talk specific use cases and things like that. But they're great questions. So I'm going to hit deploy API, and that's all it takes. So now what we're doing is deploying an API. Done. Now, I'm going to go back to my web APIs here, which show us all of our deployed APIs. So here we can see the one that I've just deployed here with the accuracy of 50% and when it was deployed. But I'm going to skip to this one, which again I made a bit earlier, and there's a reason for that, and that's that I want to go for the higher accuracy one rather than one that we just built there in about 60 seconds. So from here, we've got a cool feature. So we can view the documentation. So we can view the web API documentation. We can run tests. We can see details of the endpoint. We can view sample code, so code samples of how to integrate it into apps, that kind of thing, all available from here. But the other thing that I think is really cool and really useful for debugging your system is we can also do classification right here. So I am going to go to my desktop here. I've got a few birds, bird A, B, and bird C. So what I'm going to do is drag a photo of my bird and let it go on here. So it's uploading that photo of a bird now from my desktop to the Vision service, and it will run a classification on it. So it lets me debug and see what's going on right here in the browser. So we're classifying that bird. It's taking a while to upload. I apologize. That's my internet connection. And the fact that I'm going through a VPN and I've got a web app running. But it's uploading that photo of the bird to the system. It's going to classify it against that model, against that API endpoint, and it'll show me the result. So I can debug right here in the browser. Right, done. Okay, perfect. So here we are. We've got our classification back. Now, again, disclaimer, you'll notice that we're 100% confident that this is the Uragus, which I have to take its word for it. I believe that little red one is the Uragus, and I believe that's how you pronounce it. And it's 100% confident because I borrowed it from the training data set 2 seconds before I jumped on this webinar because I wanted to show you this point. So that's why it's 100% accurate, because it's in the training data. I know that's cheating, I'm sorry. But the other thing that is really awesome about this is if you look just to the right of that photo of the bird, we've got this like heat map. So we've got this heat map. Now, what does that mean? Well, that's showing us what bits of the model activated. So this is telling us what bit of the image made PowerAI Vision say that it was that type of bird. Why has it activated there? What's the reason behind that? And as you can see, it's activating over here, which is obviously where our bird is, but particularly where the head of the bird is. So it's this bit that our model thinks is particularly Uragus-like, which is awesome, because this is a really good way of diagnosing whether or not your model is classifying the thing you were looking for or just something random in the image. For instance, if all of our photos of this bird were taken with a green background and all of our photos of seagulls were taken with a blue background, we might find that our model was actually detecting the background rather than the photo of the bird in it. And this lets you really quickly debug that and check and see that you're classifying the thing you're looking for. So it's a really good way of debugging and testing on the fly. So you can see what's happening when your model's in production. You can see why it's classifying things the way it is. Really powerful tool. Okay, so that's it. In about 10 minutes there, we've gone through the end-to-end process of building a data set, building a model for the data set, training that model, and then deploying it as a web API. In fact, we've even tested the web API, and we've done that in about 10 minutes, going through the end-to-end process. So it lets you get started really quickly. But the next step is to integrate that into our application, right? So let's flip over to Xcode. So this is Xcode, which is where you write your iOS applications or Mac applications. This is their standard IDE, their standard development environment, for those of you that have not seen it. Just a quick tour, we've got Play up here, which lets us run it on a simulator. We've got our app name, things like that. We've got our files here. So our organization of our directory structure over here on the left-hand side, and then we've got our main window over here on the right. This is the storyboard for our app. As you can see, it's pretty basic. I promised you that I was not a user experience designer. You can see that is the case. That is the case there. So here we go. We've got our label, our image view. So that's where we're going to put the image. We've also got a label at the bottom that we're going to put the confidence in. So how confident are we with that classification? And then we've got a couple of buttons. One so that we can choose an image, and one where we can upload it from the camera. So that's our entire user interface. As I told you, super basic. Very easy to extend, add more features, do the kind of thing you want, but also very basic, very quick to get up and running. Over here, in Classification View Controller, here we go. This is the code for our app. So at the top here, we've got our outlets. So this is where we connect to those different features from the user interface. So the image view, the classification label, the confidence labels there as well. And we've got our two different buttons. So that's where we define those outlets. That's where we connect to our user interface. Then here we've got a lifecycle method. This is viewDidLoad. So this is called when our view loads, so when it renders on the screen. And here we just do a bit of setup. So we just modify our user interface so that those labels just don't say the word label anymore. We also disable the camera button if there isn't a camera available, that kind of thing. We've then got our choose image functions. So we've got choose an image from a camera or choose an image from an album. Showed you those earlier on. As I said, there's only one line of code that changes, and that's the source type. So either the photo library or the camera. And then once we've done that, once this has finished, it goes to a piece of code down here. So this image picker controller function did finish picking media with info, snappy title. This is called when our image has been picked from the camera roll or uploaded. So from here, all we do is we get the image, and we put it in the middle, in that image view in the middle, and then we call this function classify image. So we classify the image for that image against our dataset, against our API. So this is the bit that we're really interested in. This bit here is classify image function. So this here we've got our URL string. So this is our API endpoint. So this is the server that we're going to talk to, and this is our API. And then we do some setup. So we say that we're doing a post request. We also say we're submitting multi-part form data. So this is about that XHR request that I was speaking about earlier on. And we get the image data. So we get the PNG representation of the image. Then all we do is we make our API request here. So up here, what we're doing is we're then making that request to the server. So we've done that setup, we've made our request, we've formatted our request, we've sent it to the server. So here we've got a couple of different functions. One is this guard function. So this basically says, if the server returns with something we weren't expecting, cancel, stop doing what you're doing. Down here, if we get a valid response, what we're doing is we are updating the two labels. So in this function, the perform UI updates on main just says, all I want you to do, if there's been a classification, is put the label of the classification in the top and the confidence of the classification in the bottom. Update those two text labels. So that's the code for our app. Let's show it working. So here it is. This is our user interface. So as we can see, the setup has now happened. So we've got, so instead of it saying label at the top here, it now says choose image to classify. So let's pick an image from the camera roll. As I said, I've not got any birds in the room here with me, so I'm going to have to go for the device camera. Let's pick this chap here. There we go. So it's performed a classification here, and it's given us an accuracy. So you can see that this bird, not in our data set, but we've still got a really high level of accuracy. So it's come back at, we're 99% confident that this bird belongs to this category. Now I'm feeling a bit brave, so I'm gonna try another one. Let's try this really snappy-looking seagull down here. Cross his fingers. Maybe regrets doing a second bird. Yeah, do it again. I want to do another one. Let's do this bird here. There we go. Okay, so we've got this time. Sorry, JT, are there questions?
Yes, there are some more questions, but when it's appropriate. Is it appropriate time?
Yeah, for sure. So that's it integrated into the iOS app. All I was going to do now is switch back to the deck and show you this. So the only line of code you need to change to integrate this into your app is that line. This line here, so I've grayed out all the stuff that you don't need to change, you don't need to modify, and just left that one line in here. All you have to do is change that API endpoint, and it will then start to classify images based on your use case. So it's really quick, really simple to get up and running, and you can integrate this into your kind of applications right now. But yeah, let's fire away. Let's go for some questions.
Okay, so one of these questions was, you said in this case, training is happening with 4 GPUs. So Pablo's asking, can he potentially install the tool in his development box for free, or is there a license charge to use the platform?
Yeah, fantastic question. So this, but I believe we're GA now. So this was available in technology preview. There are cloud instances of it where you can get access to it and you can try it out and you can start to experiment with it. I can send, I'll make sure that we add links to those. I've not included them in this deck, but there's a couple of different places where you can go and get access in the cloud and start to try with it. But yeah, it needs to be kind of running on a power system. So even though we're using GPUs, it does need to be our infrastructure.
Okay, cool. How many pictures and how long did it take to train the higher accuracy model? You know, you had an example of 95 and
yeah, sure. So the more accurate example took somewhere between 6 and 10 minutes. So not long at all, really. Just a bit constrained for webinar time. But yes, it doesn't take much longer at all. And we've got about 20 images per category. So we've not got many images per category. Having said that, the birds we've chosen, the birds in this data set, are really distinct. So you can get away with having fewer of them. If you've got things that are much closer together, much more similar, then obviously you'd need more images. But yeah, you don't necessarily need thousands of images to make this happen. We've done it with 20 or so in this example.
Okay. Another question was, can we test it with a photo from outside the library to see if it works in real life like scenario, which I think you did with your camera roll. Yeah,
I did through the app, yeah, through the camera roll, proved that was a thing. I can try showing the heat map. Give me 1 second. Are there any other questions before I?
No. Oh, yes, one more. So the backend is PowerAI. Are there any examples of Linux front-end apps, either web-based or native Linux, coded in Python, etc.?
For the front end?
Yeah.
As instead of an iPhone app. Yeah, 100%. Yeah. So we don't. So I've done an iOS example in this one, but yeah, we've got lots of different examples that we can walk you through. In fact, we are actually running this bird classifier running in a Node.js app running on a Linux box. So we've got that too. So there's lots of different stuff we can talk you through, provide code samples for whatever it is you need. It doesn't just have to be iOS or Android. Okay, cool. So I'm going to pick random photo, which I can promise you is not in the data set. I think this chap here, he looks good to me, sitting on his little stick. There we go. So we've picked him. Let's go over here. There we go. So it's come back again with a really accuracy, massive confidence about that. And again, it's activated around the head. So it's the head that it thinks is particularly distinct in this model. I can try another one. Let's try these two. Look, these two chaps just sitting here. Let's do these. See how we get on. There we go. So same accuracy again, and actually it thinks so it's activated around both of the heads. So it's seen those, and it's the same bits that are activating in the image. So we're getting a high confidence. I can assure you that this double bird example isn't in the data set, so it's still super confident even for stuff that's not in there. I got a bit unlucky that all three of them it's 100% confident on, but as you can see, it does the same thing wherever you are. One of the things that might be interesting, let's see if we can break it. Let's say, let's pick this app, which looks more like a drawing of a bird than an actual photo bird, and see what it says. Are there any other questions, by the way? I could do this all day.
Another one's just come in. Hold on.
Yeah, sure.
Okay, so the models used are pre-trained.
There we go. Wrong this time. So the cartoon bird confused it. There we go. So it did get that wrong. So no cartoons, only photos of real birds, please. Sorry, Jyoti, I interrupted you.
That's okay. The model used are pre-trained using a specific architecture, AlexNet or VGG, etc. And do you provide these details? Can we potentially get into that level of code and change the structure to try different results? For example, if I wanted to create a BCNN, bilinear CNN for fine-grained recognition.
Yes, 100% is the answer. I'm happy to go into more detail and explain exactly how you do that if you'd like, although might be a topic for offline. So please do get in touch and we can go through that. But yes, you can. And in the cloud instances that I'll make sure we send out links to, you can do that. So you can either customize the network as it's defined in here, or upload your complete own network. So if you want to try something that isn't necessarily in the tool, then yeah, 100% go forward, upload your own networks, your own custom models for your own specific use cases, and upload those through this tool. It's trivial to do and to manipulate that, but you're completely right into how this is operating. It's transfer learning on existing networks, and there's lots of different ones in there under the covers.
The different scenario that Philip has suggested is seagull in a different position than sitting, are you flying, or a bird other than a seagull?
Yeah.
They're really testing you, Chris.
I know. Well, I mean, not me so much, but AI Vision is getting a serious workout today.
Yeah.
Let's see how we get on. There we go. We handle flying as well, and this is done by, in the data set, we've got pictures of these birds flying. That's how we're doing it. So that's kind of what we've gone with there. So as long as the birds are in the data set, let's check out this chap as well. Then he's low resolution. I don't know how well we'll get on there. Let's put this guy. He's got some motion blur as well. That's very dramatic. I'll do this one. Are there any other questions?
Nothing more that I thought. Hang on, another one's coming. Would you attach the Xcode files, as I'm quite curious to read the code more in detail to make certain coding?
Yeah, of course. So here we are. We've got Laris 99% accurate. It's a bit less confident this time when we've got some motion blur involved. But again, different positions, different birds, not necessarily in the data set. It's still activating, and it's the head/beak bit that's clearly the differentiator. Yes, 100%. The code is on GitHub. I'm going to flip back to my slides, to prevent me uploading thousands of photos of birds, but also just to show you this stuff. The first thing is we have a version of this running in production, but instead of classifying birds, we're classifying photos of beer. You know, we had some spare time. We thought that would be fun. So if you search for PowerAI on the App Store, you can download this. And it does kind of Peroni and Corona and those common ones. You just upload a photo of the bird, of the beer rather, and it'll classify it. So we've got this in production. Go and download it. It's a bit of fun. That's PowerAI on the App Store. But to answer the question more accurately, where is the code? Here it is. So if you go to github.com/ChrisParsonsDev/vision_iOS that Jyoti just popped in the chat there, and you hit up that link, then you can get access to all the code and do what you want with it, really. Start to create cool things and integrate it into your apps.
And please share with us what you're trying.
Oh, yeah. I'd love to see what you create. And please do something about my user interface.
Okay, no more questions that I can see. So if you've got any questions, please type them into the chat window.
Yeah, please do. And again, I'm happy to hang around for the next kind of few minutes or so and see if any other questions come through. But I hope this has been useful. Hope it's been a good demo of the technology and how quickly you can get started. And you know, reach out to me on Twitter @ChrisParsonsDev or drop Jyoti or me an email if you've got any other specific questions. Happy to kind of help out and work with you and build awesome things.
Yes, thank you, Chris. I'm just going to remind people that this session has been recorded, so we will share the replay later on today. Perhaps if I grab control, I can tell people about the next sessions, and then...
I have stopped sharing. Let me make you a presenter.
Thank you very much.
No problemo.
So to remind people that we will be having another few sessions, just going to put up some details. And please continue to type questions into the chat window while I talk through this. So the next session is the IBM Cloud Private session in the Power Virtual User Group series. That will be running in June the 7th. Tom Watts will be covering that, and I will send out more details in the replay email that I send after the session. And then a reminder that the replays for the Power Virtual User Group technical webinar series, as well as Joe Armstrong's Power Systems Virtual User Group series, are now on a YouTube channel. So it's a single YouTube channel for both our virtual user groups. So please visit and subscribe if you haven't already. And then tomorrow evening, we're running a face-to-face meetup for PowerAI in London. And I'll post details, the links of that meetup group into the chat window. You can see it on the left-hand side of the screen. So hope you can join us on that session. Chris, did you want to say anything about this particular meetup tomorrow?
Well, I mean, no, I think that was an awesome summary. I mean, sadly, I can't be there, but it will be great. And actually, we've kind of followed some feedback from the community, which was, please show us more use cases. So we've got a bunch of IBM consultants over from our worldwide team, so come from as far away as Australia and Japan and North America, and who've been actually using this tech in customer scenarios and the challenges, that kind of thing. So that should be kind of really interesting.
Great. I hope that you'll be there tomorrow, if you can make it, look out for me and come and say hello. I'd like to be there. And then on the 21st of June, we have a briefing that is specific to financial services industry. Again in London, that's a daytime face-to-face meeting or briefing. And I'll pop the link into the chat window as well as send via the email when I send the replay details later on. So hope you can join us with that as well. That's it from me. Is there any questions? Take a look. No more questions that I can see. I don't know if you've got anything privately, Chris?
I hadn't checked. Nope.
Okay, well, in that case, thank you all very much for joining. Thanks again to Chris for giving us a great overview of how you can do this and build an app. So hope to catch you all next time. I'm going to stop the recording. We can stay on for a few more minutes for questions. Thanks again.